Hello, today I want to talk about native modules in React Native. Lately, there has been a lot of innovation, a lot of module systems have been created in the last couple of years. And it's getting to the point where it's just kind of confusing to know which tool to use, what are the benefits, what are the drawbacks. And if you're not really deep into writing modules and know kind of all the internals of React Native, it might be a really hard choice to do where to write your native module if you need one of these frameworks. So I thought maybe give a very quick overview is useful. So I'm just going to go through a guide that I wrote for my clients. It's on my website. The link will be in the description. But basically just kind of goes through all of the terminology that we use, all of the module systems. It's a very high level overview. It doesn't go into details of how the code works. But even then, I think it's quite useful to know the pros and the cons of each one of the module systems. So to start, you should be familiar right now with the old architecture and the new architecture, but the old architecture is dead. It has now been removed from React Native, so it doesn't really matter anymore. So now we only have the new architecture. And the new architecture is the combination of the JSI, Fabric, and Turbo modules. So JSI is kind of the core piece of all of the stuff that has been built lately. It's basically C++ headers and functions that allow to call the JavaScript engine functions, right? And allow you to inject values, allow you to get values, allow you to do callbacks, all of this stuff via C++ code. And there are some peculiarities about using C++ code to interact with the JavaScript machine, mostly because the JavaScript machine kind of has its own state, right? It's already running. It has its own heap, so you need to take care of certain things once you start using the C++ code, which brings its own difficulty, right? Like C++, it's already difficult to write and to understand and handle pointers and memory. And then on top of that, you kind of have to understand how these JavaScript engines work. Next, we have Fabric, which is kind of the UI layer. I don't go into this because most of the time you will probably not touch this unless you're kind of writing your own UI components or you're writing your own UI library. But most people will probably not get super deep into this. And finally, you have Turbo modules, which is the first module system that we're going to talk about. Turbo modules are the module system that's integrated into React Native, so it doesn't require any third-party packages. And basically allow you to define interface in TypeScript or Flow, and then it generates a bunch of C++ code. You then take that generated code and you kind of create your own functions implementing those interfaces. And they generate Objective-C and Java Kotlin code. Now, there are some drawbacks to Turbo modules because they use this code gen system. In my experience, it has been very painful to deal with it. They promise not to break between versions, but it has broke before. And documentation is not great. I think in the latest versions it has improved quite a bit in like the official side, but there's still like kind of floating around many things that are not super well defined. So this is kind of the official way of writing modules nowadays, but it's kind of lacking, right? It's kind of still very difficult to set it up, to even create internal modules for your app. So this is, I think, why so many module systems have popped up, right? Because Turbo modules are just not the easiest ones to use, especially from like a developer perspective, not from like a core React Native contributor perspective. So then we have Expo modules. Now, Expo modules are built on top of like the JSI foundation. Like all of them are now built on top of the JSI foundation. But the good part about Expo is that they do control like their own framework, right? Like they have modified React Native in a way that it allows them to bootstrap a lot of their own code. So the entire module system is built into Expo, right? And that gives them a lot of flexibility to get the functionality that you would get from like having ownership of React Native yourself. So they are by far the easiest ones to set up, right? You only drop like a couple of configuration files, drop it in a folder, and Expo will kind of automatically pick up your module, right? They don't require like funny schemas. They don't require like a lot of knowledge in whatever it is you need to know about the internal systems of Expo. They really focus on making the developer experience as easy as possible. Now, there is a drawback with Expo modules, which is they're not the fastest. The priority was getting the developer experience to be as smooth as possible, but they can be quite slow. Expo themselves uses all of this code, so it is good enough to build Expo itself, but sometimes it might not be enough, right? Like if you're writing a high performance library like a database or some sort of rendering engine, or you need I don't know, whatever it is you need, it might not be enough for your use case. But they're good enough, right? Like I think if you're already on Expo, the best thing to do is to start with an Expo module, get your idea fleshed out, and then if at some point you realize you need more performance, then you can jump to the next module systems. Now, I wrote here the JSI C++ module. This is not really a module system. This is kind of, the initialization starts as a turbo module, but then we quickly ditch out all of the turbo module stuff. And once we have access to a few of the objects on runtime, then you can write pure C++ that interacts with the JSI code, right? And in terms of performance, this is going to be the fastest, just as plain as that, right? Like there's no abstraction layer, there's no translation between languages. You can call Objective-C, you can write your own bindings via JNI for Java and Kotlin, but that's where the difficulty lies, right? Like you have to write a lot of code, a lot of boilerplate code, not only with Kotlin and Swift and Objective-C, but also with just C++, right? Because this is kind of the low-level abstraction of things. And if you're not an expert on C++, on Objective-C, on Kotlin, on JNI, on Gradle, on CMake, and all of these build systems, it's just super difficult to kind of get it work. That is the truth, right? So for a long time, the people that were not writing Expo modules or turbo modules, we were writing like this manually typed C++ code. And it's kind of a pain in the ass, right? The good part of it is that once you kind of get over that small initialization cost, you're basically interacting with the pure C++ code. Nothing is going to get in your way. You have control of memory. It will very likely not break, because that would mean that they would break all the compatibility with the previous versions. So there is some benefit to doing this quite large amount of work. Now, Nitro modules kind of came of the pain of writing these pure JSI C++ modules. And they were written by Mark, and Mark already had a bunch of like C++ modules, and it's just a lot of work to maintain them. And over time, he started to realize patterns and abstractions, so he kind of started abstracting all of this away. And at some point, he realized you can wrap all of this stuff in like its own module system, right? And you can create your own code generation that might be more stable than the turbo modules one. You can create abstractions on top of the raw JSI objects that make it easier, nicer, closer to, let's say, Expo modules for regular developers to develop their own modules. And that's kind of the combination of all of those ideas is Nitro modules, right? They are probably as fast as JSI C++ module. I mean, it is an abstraction. I haven't measured myself how much of a cost they bring, but they are definitely faster than either a turbo module or Expo module. Way faster than an Expo module. But they do have some risks, right? So they are created by Mark. He's the main contributor. So it's kind of an individual supporting the entire module system. And it's, again, another system that you kind of need to learn. Despite all of the easiness to create your own bindings once it's set up, it does require setup. It does require for you to install Nitro modules in your system. There have been some breaking changes or some bugs between versions in Nitro modules. So again, some downsides. And finally, the newest one is the Node API modules that started very experimental. It's still very experimental. They're backed by ColdStack and some great developers. And the basic idea is that they allow you to write native modules using Node's NAPI. So NAPI is in Node world how you create native modules. You write again kind of C++ code, and it's exposed to the JS side of things. And the great thing about Node API modules and using the NAPI system, it is that it kind of gives you access to the whole NAPI world, right? So any Node.js module should be able to run now on top of JavaScript or React Native. And this is great, right? Like you can also write your own module, right? In like C++ or Rust or whatever that generates a NAPI module. Get it to run on React Native, and in theory, it should also run in just pure Node. So it allows you to test your module without all of the, mobile, iOS, Android, React Native, yada yada yada, libraries and code and runtimes and all of this stuff. So it kind of makes it a little bit more predictable, more stable. I haven't checked if you can write or you can bind to Swift Kotlin code. Probably not the use case. But in any case, they're still very experimental. They're still very fresh. So still to be seen if it survives the test of time. Now, what should you pick, right, among all of these options? Here's my take on this. If you just want to call some Swift or Kotlin and you're already on Expo, by leaps and bounds, this is the least painful option, Expo modules. They will just work. They're far easier to write. They're far easier to maintain. They don't require a lot of boilerplate code. They're just the easiest by far. They can be quite slow. They do require Expo, but nowadays everybody's using Expo anyways. So at least I would say you should first try Expo modules. If they work and they're good enough for your use case, then don't change. It's going to be the easiest one. If you require the most amount of performance and you have extensive C++, Java, Android, Objective-C, iOS knowledge, then a JSI, C++ pure module, no turbo module, no nitro module, that might be a good option for you, right? Like it does have some benefits despite the huge amount of knowledge that you need. You probably, if you are not a library maintainer, you don't want to do this, but people like me or some of the agencies, we can make this work. If you require the best performance on par with a JSI C++ module, but you're not super familiar with all of the native stuff, and you're willing to kind of take a little bit of a risk with a third-party module system, then you can try Nitro modules. If you can get them to work for you, I think they're super nice. Again, they give you the best performance, but again, it's a little bit relative. One should be careful with how you benchmark things for your use case, even though it might not give you the huge amount of performance that you're looking for. And if you want most of the performance, it's not the most performant, but you don't want Expo, you don't want third-party packages, then you can write a turbo module. There are some complexities there to manage to get it to work, but once you get to work, it will just work because it is integrated into React Native, right? Like that is now the way to write modules. And there's some risks, but you want Node compatibility, then you can give the Node API modules a try. That's what it is. Very experimental, do it on your own risk. So some questions that people keep asking me, is it possible to have a new Arc that's compatible with the old Arc? Well, the old Arc is gone, so this is dead now. Do you like turbo modules? No, I don't. CodeGen has been the bane of my life. Any type of CodeGen over my engineering years, it always fails. It's painful to deal with. I just don't like it. Expo, blah, blah, blah. Go ask the Expo guys. Like I said, I already think Expo modules are quite good. I don't know what else to say about that. You can ask them. JSI is C++. How come turbo modules are Objective-C, Kotlin, and Java? This also applies to like Expo modules and nitrogen and all of this stuff. It's again the same thing, like any language compatibility will work. There are compatibility layers between C, Objective-C, then C++, between Kotlin, then you go to Java, then you go to C++, yada yada yada. That is just the reality of making interoperability work between languages. Can I write a turbo module in Swift? Basically, no. No. Go for Expo modules. Go for Nitro modules. When will I be able to write turbo module in Swift? Probably never at this point. Forget about it. Can I write a native module in Rust? Yes, you can. I have articles on my website. I have some videos on this. I have been doing a lot of Rust on React Native. That being said, I do manual bindings. I don't use any of the module systems. Might not be your use case, but I'm kind of an expert on the topic. I like it that way, but it is definitely possible. And pitfalls of writing native modules, you do require some native knowledge. The modules can abstract a lot of things for you, but every once in a while you will hit errors. Okay, I don't want to make this video any longer. Thank you very much for watching. If you have any more questions, post them in the comments, and